Hello. Okay.
Sir, please send that today's
Link.
To all easy family. Day one.
Day one. But here I have written something else. Join day one YouTube link. Please join at 9:30. Accept this. Take it, same na? Okay, I will copy the link and then I will first send you. Okay. Now check this. हेलो हाँ वो अभी hello, this is for testing. You are getting the voice. This is for testing. Are you getting the voice? Guys, you are getting? Sound is on. Yes, yes.
Okay, audio, video.
Madam, I sent to EC family. There you write join at 9:20 like that. Eh? Sir is asking for our speaker. He is joining.
Okay.
I will make him admit. Then I will tell you after 15 minutes, 20 minutes. See, you are also there? No.
That's it.
Hello.
अरे हाँ रुक जाओ, अभी ना कुछ टेस्ट कर रहे हैं, रुक जाओ. No, now sir is there na. Good evening, sir.
Hi, good morning. So maybe I try to share my PowerPoint if you can put it in there. Let me see.
Yes.
A window.
You use entire screen, your entire screen.
Okay. This is the window I want to share.
So when you click the present now, then you get two options: your entire screen and window. You use your entire screen.
Do you see me? Do you see the window?
Yes. Now it is coming. Telepresence Robot Empowerment Smart Lab.
So you see the PowerPoint?
Yes.
So you see the PowerPoint? It's working, eh?
Yeah. It's working, sir.
Okay, that's great. That's great.
Yes.
So you still have a mask indoor?
No one is here now. Now I remove, and we will after 10 minutes, 10, 15 minutes. After 10 or 15 minutes, right?
Oh, okay. So everything work is fine. So I just leave it alone, and
Yes,
uh, I come back 10 o'clock in my
After 10,
time.
after how much minute?
Pardon me?
You will come after how many minutes?
Oh, I come in with 10 minutes or something.
Yes. Fine, sir.
Yeah,
Fine.
because you have allowed 20 minutes. 20.
Yes. After 10 minutes, you join, sir. No problem. You keep it as it is.
No. I leave like this. I don't. I
Ah,
don't move anymore. Leave like this.
yeah.
Okay.
Yes, sir.
Okay. How are you? I don't have anything. I just want to say I don't want to keep you here. So
We are just setting the setup because this program will be live also.
okay. So yeah, I will see. Thank you for inviting me for this. I appreciate. I hope through this kind of communication and exchange. Basically, today I will be focused on the 30% smart lab, but I can also introduce some of my research, previous research, and what I'm dealing with the research and development. Share this information with you guys. Okay.
In fact, sir, we are honored, sir. We are
Okay.
honored that you accepted our invitation for this program.
Yeah. So actually, do you know there is a program grant between
Yeah.
India and Canada?
Okay, sir. Yes, sir.
There is a grant we could apply for send your postdoctor or doctor students come to Canada, work for several weeks, a month, and so on. There's a Indian Canada grant called SHARIC, something like
Okay,
that.
right, sir.
Yeah.
Right, sir.
Maybe in the future we can looking for this kind of collaboration.
Yeah, definitely, sir.
Wow.
Okay, sir. For 10 minutes, you can take rest. After that, you can join. No problem.
Okay, sure. Okay, thank you. Just leave
Thank you,
like
sir.
this. Okay,
Okay.
thank you.
Yes, sir.
Yeah,
Yes.
yeah. I just.
Hello, testing. This is a testing of the voice. Hello, hello, hello.
Good morning, sir.
Good morning.
Sir, I'm Noyesh Rao, head of the Department of ECE, sir. Welcome you, sir, for this 4 days workshop on technologies for teaching, learning, pedagogy. First of all, I would like to express my sincere thanks to you, sir, for accepting our invitation to deliver a talk on during this workshop, FDP, sir. Thank you very much, sir. Hello, sir. Code, sir. No code, sir. Just I clicked, I got it, sir. No. 1 minute, sir. Misra, sir.
So can you hear me? Can you hear me?
Sir.
Hello? I'm here.
No, sir. No, sir. This is first. This is second time, sir. Earlier we did it through one meeting, but you are not invited through that.
Okay, okay, okay.
Hello again.
Good morning, sir.
Good morning.
Yes. Good morning to everyone. I am Dr. Yogesh Mishra, Professor in Electronics and Communication Engineering Department of GMR Institute of Technology, India. Welcome today's distinguished speaker, Professor Cheng Tian from Athabasca University, Canada. Dr. CLV RSV Prasad, Principal, GMR IT. Dr. J. Raja Murugdas, Vice Principal, GMR IT. Dr. M.V. Nageshwara Rao, Professor and Head, ECE Department, GMR IT.
Thank you,
It is
sir.
my pleasure to welcome all the participants who are going to attend International Faculty Development Program on Technologies for Teaching Learning Pedagogy from 6th to 9th August 2020. This program intends to bring leading academics from the globe to share the expert knowledge regarding teaching learning pedagogy. More than 520 participants throughout the globe registered for this program. We have participants from Nigeria, Vietnam, Indonesia, Bangladesh, Thailand, Iraq, Philippines, and other countries. Now I shall invite Dr. J. Raja Murugdas, Vice Principal, GMR IT, to share his thoughts. Sir, please.
Thank you, Professor Yogesh Mishra. Am I audible?
Yes, sir.
Yes,
you are
sir.
audible.
Very good morning. First of all, I would like to congratulate the entire department as well as the organizing team for choosing a very meticulous topic, the technologies for teaching learning pedagogy. That too, that I think you are focusing on online teaching learning pedagogy. So during this pandemic, this is the need of the hour for all the teachers to align themselves, and I hope this particular workshop will take a little bit advantage to transform the conventional teacher to a 21st century promoting kind of teacher workshop. I am very sure that next 3 days, I think the participants will be much exposed to the online teaching pedagogy. As you know well, in the education system, there are 3 things to be aligned in the single track, that is curriculum design, the curriculum delivery. If you say curriculum delivery, automatically the appropriate teaching learning pedagogy comes to picture. So your teaching pedagogy as well as the assessment, all the 3 major pillars to be aligned in a single track so that you can yield the result. And also you know that now the new educational policy 2020 is also speaking about the same concept of STEM education, outcome based education, everything. I think I congratulate the organizing team, and more particularly I would like to appreciate and thank the external experts from Canada for accepting our kind invitation and to be a part of the workshop as a resource person. Thank you, Professor.
Thank you.
Hello.
Thank you.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Yes.
So thank you, Professor. Wish you all the best for the next. I request the participants to make use of. Thank you. I request the participant to make use of this 3 days workshop to transform ourselves first, so that our education system, the quality of education will be enhanced in the coming days. So the transformation is very much needed from this teacher's perspective. Wish you all the best. Thank you.
Thank you very much, sir.
Thank you, sir. Thank you, sir, for your words. Now, it is my proud privilege to present the brief biodata of today's distinguished speaker to you all. Dr. Ching Tang is Associate Professor in the School of Computing and Information Systems at Athabasca University, Canada. He earned his PhD in Cybernetics Engineering for Robotics from the Norwegian Institute of Technology, Norway in 1993. His research interests include location-based technologies, mobile computing, adaptive mobile learning, computer network and security, cloud computing, Internet of Things, big data, cyber physical system, and telepresence robotics. His recent research mainly focuses on the telepresence robot empowerment smart lab and privacy issues and societal impacts of emerging technology. Now I shall invite Dr. Ching Tang to deliver his talk on telepresence smart lab for the event. Sir, please.
Thank you. How long time I have?
Sir, as per your wish, sir. As per your wish, sir.
Okay. Okay. First of all, thank you, Professor Misra, and also Professor Jaraji. I hope I pronounced it right. I'm honored to be invited here to give this talk. So, and also, this is the first time for me have this direct interaction with the GMR Institute. So I just take a little bit time to review your institute, your location, and so on. It's quite impressive. And I see that in the summer, maybe you are in a very hot time now. Right in the plus 45 degrees to 24 degrees. On the lower side, where I located in Canada, Alberta, Edmonton, in the winter time, we could have weather like a minus 45. So we have a 90 degrees difference. So it's very nice to have this opportunity to talk here. And now I'm going to thank you, everybody. Then I'm going to start my presentations. So today's my presentation's topic is telepresence robots empowered smart lab. I call the TRISO and beyond. So let's move. Cursor. So today, you see there again. First of all, first of all, I found from that invitation and the what's your brochure. I found that today almost like the Athabasca University sessions. Followed up by me, and there's another two colleagues of mine will be do their presentation too. So anyway, so I can start to introduce a little bit about our university. Then I give more focus on the TRISO, the telepresence robots enabled smart lab, and then I'm going to introduce some the location-based mobile learning, adaptive learning, what I have been involved previously a lot. And I'm going to use this opportunity to introduce some other research and development project I'm involved with. Then I'm going to have a remark. So Athabasca University was start at 1972. So when maybe this slide can talk about this. Yeah, in the 1972. So when it is it's a pioneer and leaders in the distance learning in the world, because in Canada, this university is a public university. So in Canada, university is funded by the provincial. So in our province called Alberta, there are many universities and colleges, but there is only 4 research comprehensive university funded by government. That is a public. So Athabasca University is one of them. And Athabasca University started with 1972, as I mentioned before. It is because of Alberta in size, almost like the French. We have only 3 million people here. So the people scattered everywhere. In that time, Alberta government want to provide the people have everybody, no matter where you live, what do you work or full-time or part-time, have the opportunity to get post-secondary educations. So this university was built because of that. That is already, this year we are celebrate our university 50-year anniversary. So Athabasca University program, we include the main courses and also a lot of 55 undergraduate or graduate programs. Athabasca University, we have a 2 main group of students. So one we call the program students. That is the students come to Athabasca University, take their full degree in our university. Another we call the long program students. That is students who are coming from another university. They just coming to take 1 course or 2 courses and so on. But they're also take this course and get the pass the exam, get the credit, bring the credit back to the home university. So we call the long program students. So far in this university, we have arts and business, computer and technology, and basically we have the science, and we call the science and the technology faculty. And we have a distance learning education, nursing and health and science I already mentioned there. So in Athabasca University, we also been involved with various type of research. Why we are focused on our mission critical, like the learning technology and so on. We also developed a different research program and from academically and also practically practical applied research. So this is and also we there is a lot of national or international funding and also provincial funding to fund our research. So this distance learning basically is a kind of we're started very early, but now it's become like the trend. And also, as nowadays in this COVID-19 pandemic, so a lot of university and turn to online. So they're starting to practice almost similar like us to practice teaching online. But in the most case, the teaching now is online, but it's synchronized. But in our teaching in our university is unsynchronized. So basically, professors divide the course and put online. Then we have a tutor. Then the student come online through the learning management system to take their course and do the assignment and pass the exam and so on. So the professors and the tutors just get ready there to help them to go through the courses. So distance learning, of course, there's some advantage we can see is the in the Athabasca, basically we're open, so you can do it's not as online, you can do it anywhere, and you can do the part-time. We have a lot of people who are working and also take their degree at our university. Not of a stay-home mom, daddy. They also, while they take care of their family, also come to our university to complete their degree, or when they're changing their career and so on, then they also come to us to get this lesser education and trainings. And because of distance learning, they provide the strong tool, the opportunity for us to implement so-called disruptive pedagogy that is more referred to personalized or the adaptive learning. And in the online, in the distance, so we could implement education technology intensively. So the distance learning, of course, there is the trains and the transitions. It's well known for everybody. It's called the e-learning. That means the digital learning material and the learning online. Online learning is particularly focused on online. So you use computer online, and there is also mobile learning. Use the mobile device to the learning. And recently, not recently, but about 10 years now, there is called the MOOC, that is massive open online courses. That means there's a different university divide different courses, put online. People can freely go to take the course. Then you pay for passing the exam and pay for the credit and so on. So they call the MOOC. And also there's also another trend is called the open education resource. So that means there's a movement with international support by UNICEF. Basically, it's people can divide the courses or learning materials and share by worldwide, share the publicly anyway. So yeah, we're talking about e-learning. Basically, e-learning is through the internet, the computer as media. So we start to the learning, and basically for the e-learning, there is something good, something not very good. So what the good part is that because the e-learning, we can learning from the students. So we can profiling the students from the students' learning style, learning profile, and learning behaviors. So we can do the profiling. So therefore, we can deliver our course or course contents be personalized and adapted to the students. And also, it's very convenient and flexible. And basically, students can do the learning anytime, anywhere. And also for the time wise, so from e-learning, they have a use a less time and also the cost more cost effective for the students, and also help the students. Maybe that is not for the younger generation anymore. It's for the generation, not a younger generation. It's becoming digital native. This is not the issue at all. But for the people a little bit older age, or the baby boomers and so on, so because online they have to use computer, has to use the network. So this e-learning also force them to develop the use computer skills, and also because of the e-learning, they also have developed their own knowledge and confidence. The negative side is e-learning is the students basically, especially for the unsynchronized, the learners, students usually difficult to motivate it. There could be very procrastinating, and so this motivation is one of the big issue. And also students could feel isolated because they don't have a classmate around, and even so anything through they want to have a question and submit the assignment and so on, all through the email and through online means, so that it could make them feel like isolations. And instructor availability is also the limitation, because there's no instructor sitting there waiting for you to answer your questions and so on. For instance, for our university, we still have the schedule of open Monday 8 o'clock to 4:30 in the afternoon, and Monday to Friday. If a Saturday weekend, we are not supposed to work. But anyway, this depends on each individual instructors and professors. But the university will be not required for that. That means when the students really need help, maybe we are not available in there. And also depending on the quality of internet. Even nowadays, the internet seems like it's very mature, and technology is ready, very much ready there. But we still have an issue. Sometimes we lack of the proper internet connections. So this could be also the very much constraint for the course delivery and for the learning, and also for the hand-on difficulties. So do the lab work. For instance, we have science courses. They need to do some lab work for their credits. Then it become a problem. So because today's focus is about the 30% smart lab. So I want to see that, just mentioned before, there is one of the disadvantage of the distance learning is lab work, hand-on. So how we do now, first of all, we do lab in the demonstration for instance, just show the lab, almost like the play video and so on. This is the type of things. And this could be, we could fund of this. But in our practice, for our science center, they could, what they do is send the lab kits to the student. Students receive the lab through a mail system. Students receive the kits and then follow the instruction, do their lab work at home, and take a video or pictures and submit their lab report. Then send the kids back to school. And also we also doing some occasionally, for instance, the end of August or something, August, then people take a 2 weeks vacation, coming to our university as a Pascal location, then go to our real lab, science lab, to do the concentrate the 2 weeks just to do the lab work. So we have and also we also contract different, for instance, our nursing program, contract different institution or hospital or whatever. Then maybe students can do the hand-on lab work nearby them. So this is how we solve this issue. But when we come into the traditionally online e-learning lab work, there's as here is mentioned, for demonstration is one thing, just to show you what the lab works. So if log on, you see how the lab process, just basically show like the show and tell. And also we also do the lab, do the simulation. For instance, there's pre-designed program and so on. You can just running software, trigger software to do the simulation and so on, put your own parameter and so on to see what happens for the. So this is a simulation, a lab by simulation. And the virtual lab basically is create the virtual environment, like for instance, use Wonderland, Second Life, this type of things. You create a virtual lab, and the people create their own virtual avatar to see almost simulate in a lab case. So that is also the case. And remote lab is basically a lab in a remote location. In the particular lab design, students can log on online through certain interface to trigger some buttons and so on, to trigger some do some lab work. Basically, they can hand on, they can put something online and then trigger whatever or the chemical reaction or whatever, the pre-prepared lab, but this real lab, but you do it remotely. This is also what we see. So because of this situation, what I just want to do is I want to develop a solution for take care and deal with this lab work issue. So I come out, the idea is use the telepresence lab, telepresence robot. Put the telepresence robot in the lab physically, then students could online sign up to the robot. Then this robot will become this student's avatar. The student can drive and manipulate this robot to do the lab work. So this is a further step of the remote lab. So telepresence technology has been there for a while. So telepresence basically is about the two locations: your physical location, local location, and the remote locations. So from a technology, how to present a person in a remote area, remote locations. So therefore, the final goal of this telepresence robot enabled lab we want to reach is one is called the be there. That means psychologically let the learner, the people, the user, through this telepresence robot, through this telepresence system, enable them to psychologically feeling they were present in the remote lab. And another thing is acting there. That means through this telepresence systems, they can extend their interactive capability, including their sensoring. That means that they can see, they can hear, even they can feeling, and the communication, talking, and speaking, and also a mechanical capability. That means manipulate the robot hand and so on to interact with the lab work and the environment. So that is two ultimate goal. This is the basically the concept, the picture of the telepresence, this telepresence system. Here we are include different modules. Sorry. So basically, the people sitting online through the internet, they can drive the indoor robot, the telepresence robot, as an avatar. Inside the lab is equipped with all the sensors and different technology, heavily equipped. That means use Internet of Things and also use a wireless sensory network, create a mesh network of Internet of Things. So therefore, the people and can engage with this we call so-called smart lab. In this system concept, we are basically talk about the five, actually should be five main modules. One is for the control module. We are more talk about how we control the robot and the driving robot and so on. And one is the security, and one is application. For the application, that side is we for instance support the different learning algorithm, or is for learning analytics. Then we have learning analytics and so on. This kind of different modules. And one of the important modules here is didn't draw is human interface modules. This is the architecture of this system. For instance, you see the students, instructors, and the system admin as a people through the human computer interface, this kind of module. Then we all this module could compose of just application, web-based application portal, or could be virtual reality interface, could be used natural language processing devices, and so on, to interact with the system, that is interact with the robot on this IoT smart lab. Then from the data link layer is from remote. Of course, we rely on the internet connections through the internet, and the delivery, we could deliver this lab as kind of cloud services. So in the lab, first of all, we see the so-called Internet of Things. That is all the components we can implement and so on is all uniquely addressable electronics. So that is, for instance, robotics. Telepresence robot is one of the things in the inside this network, inside in this Internet of the Things network, and also smart sensoring system, and also the lab equipment and so on. This is one part. And another part is we call the lab services. All the smart lab services is all the key modules of this system. It's a security module, control module, and application module, and also the analytics module. All this module is located local on the remote lab, physical lab itself. And the human computer interface, this module is basically in the client side, user side. Of course, all these modules, all this data has been supported by data learning, learning management system database, and multimedia database, and the user database, and so on. Here we talk about how we implement this 30% robot enabled smart lab. So we have three type of mode. One is a online standalone. That means the robot itself, 30% robot, is in the lab. Then students can sign on the robot anytime, anywhere, just work, use this robot avatar, driving this robot avatar, manipulate this robot avatar to do their lab work. So this is we call the online standalone. And also we call the latter module, we call the online collaboration mode. This mode, for instance, I'm in Canada, one student is in India. We can both sign up. I can sign up one robot as my avatar. The students in India also can sign on another robot as their avatar. So both of us can working together through their avatar in that remote lab. So I call the online collaboration mode. And another case we call the online and on-site blend mode. What that means is, for instance, we are doing a group lab work. One student maybe can show up physically in the remote lab, but another student can't. Another student could sign up themselves, sign on to a telepresence robot, and this telepresence robot will be their avatars. So these people who are inside the lab physically can work with their telepresence robot avatar as if they're working with their group members. So that means the robot and the person blended mode in the lab. So later here I just going to introduce a little bit more about this telepresence robot service modules. As I mentioned, there's before. So first of all, there's a security module. This security module design is basically for the user control and for the information security and also facility security, because this the 30% system is kind of a cyber physical system. It's basically allow the online people to drive some physical object, that means robot, or interact with the environment, maybe the lab or the lab tool or the device or the equipment. So therefore, security is important. So therefore, we have one module to particularly address this issue. We call the security module. Control module. In the control module, it's basically we are, besides to control the robot itself, to manipulate the robot just repeating the students' online comments by driving the robot. We talk about that is more like the manipulation that I'm going to discuss this later on. But on the other hand, we are talking about how to drive the robot. For instance, when this telepresence robot sitting in the lab, physically in the remote lab, they will be sitting in the base. But do the lab work, maybe you could go to the lab table. If you want to go lab table 1, lab table 2, lab 3. How we do that? So first of all, we can see, of course, because this is a telepresence robot, the student or user online could drive the robot manually through the manipulate the computer or rather human computer interface to drive robot manually from place A, from the base to the work lab, work table or lab table. But if the students do many time of this, could be very time consuming. So therefore, we also enable another mode we call the autonomous mode. Basically, for instance, the robot, I already did the lab 1 and lab 2. Maybe now actually we go to lab 3, table 3. So when I sign up, the robot could, I turn to the autonomous model. Then the robot can automatically moving autonomously to the particular lab table. So I call that autonomous mode. And another case is, as I mentioned, the blend mode. For instance, I have my peer, another group member who are inside the lab. So we are working together. So therefore, my robot avatar could lead by this particular person. So we call the leading mode. For instance, 3 of us, we have a person there, so that the other 2 robots will automatically follow this person, leading by this person. So we call the leading mode. Application module. Application module is basically to support this 30% systems functions and features. For instance, I will mention later on. For instance, support our learning management system. This support the 5-hour adaptations, the algorithm, and the support. For instance, we have a VR, AR, virtual MR applications. So the basically support the different feature and also to support, for instance, the cloud computing service and so on. So this any application will be dealing with this particular module we designed also in the particular physical server. Analytic module is basically we want to do the big data analytics or data analytics for in order to provide students have more personalized or adaptive learning experiences. So that is basically to support any data analytics and so on. This is one of the modules. HCI module is, I mentioned before, is basically this module will be in the server side. HCI module could be as simple as just the keyboard we are using. Use the keyboard, the key to drive the robot and so on. Or we could have a much more advanced gear, like a virtual reality gears and so on to help the students better engage students to have this 30% experiences. For so far, we have did some preliminary research, and we also have some funding, because this what we present all these systems is has been there. We have been working on this for several years, more than 2 or 3 years, from the concept, and then we try to develop the system and focus on each module and solve the practical and theoretical issues. At the same time, I also did some hand-on development to want to prove this concept. So therefore, this primary research and funding for this particular threshold has been done. Therefore, I just want to give a little bit hint about, present a little bit about this. So, from this research, we basically want to see is this usability study is basically is this usable, can be used, or is feasible at the same time. And also we want to see, for instance, can we drive the robot? What's the driving experiences for the online? And this is all the then like the lot of theoretical and more academic research topics and dealing with the research. This is a very simple implementation for the primary research. We create our own research and create our mock-up smart lab and create the system. Then we are invited about 40. This is what the robot we are created. Very simple robot. Can drive and have a hand, can raise up, open, close. This is a very detail about this primary concept proof system. This is a more silver in the left side, and the right side is more how the data goes through. So this is the architecture and the hardware and the software. This left side is show the hardware, and the right side is more like software and the information how to get through there. This is one of screenshots for this. What we see here is a user's interface. So the students can see what they're. This is a mock-up robot. For instance, a robot stand there, and people log on to the robot, then drive the robot to the table. Then this robot will be watched by. This first small picture is the external camera, basically lab camera. You can see the whole picture of the lab. Then the closer one is the one of the robot camera carry on the head camera to see what the closely see what is the things on this. The big one is the same as the closer one is see what is the lab table is. Basically, this what they did is we invited about 42 people worldwide, from grandma to the kindergarten kids, of course, university students and master students, PhD students, professors, and family and friends, cross world, from Europe to Asia to America. So to sign on to this system, basically driving robots from the base to this table, then manipulate this robot hand, grabbing the ball or grabbing the object and drop to this ball, the server ball. So that this is what the test we made. From this testing research, we basically, after the people done this, we have a series of questionnaire ask people to answer. So basically, there's a question. There's two important questions. We want how easy to navigate the robot in this remote lab, because the people the first time they sign up, they never see anything, even don't know the robots, how the robot looks like, and how this remote mock-up lab is. We want to just first experience how intuitive, how easy to drive, to navigate robot from the base to the lab table. And also, we also ask questions. For instance, do you think the robots should move more autonomously? That means because we are thinking maybe people don't want to drive robots, just want to move robots, stand on the lab table and just manipulate the robot hand to do the grabbing and drop So we just ask these questions. So we get some results here. Then I don't do the detailed analysis. Basically, what kind of results we get is from this research, we found that people almost 42 people. I think we have 39 people successfully complete all the missions. They basically sign on the robot, drive the robot to the table, and grabbing the ball, drop the ball. And most people feel quite comfortable to drive the robot. There's no issue. No matter it's young guy or old people, they're if we told them how to use, they can do that, complete this work. And the people who are more adult type and student type, we compare if the people, for instance, used to play the video game, maybe they're better in this kind of environment. But the research found there is not so much difference when they are driving this robot. So it's quite comfortable and easy. Most cases, the conclusion almost like that. And also for the autonomous, because the people said they want to, from this research, the people said we want to drive manually. So this gave us kind of a hint. So why? Because that means through the people driving the robot from a base to the table, their experience the remote lab, the lab environment, makes them more engaging, more interest to do the work. So, so in this particular case, we think that this answer makes a lot of sense. But of course, in the rare case, for instance, if you have a 10 lab you needed to do, you're already familiar with this remote lab environment, same robots from the base to the table. That could be tiring and boring. So that therefore we think implement autonomous driving is also very important. Now, I want to present a little bit about recently, so last year, end of last year, actually. There is a hackathon happens in Greece, Athens. I have a group of researchers and students working there. They call the Trashel Mixed Reality team. What they're doing, they basically create a virtual robot and a virtual environment. Then they use virtual reality gears to drive this robot to complete whatever remote lab that the primary study remote lab has been completed the things. So this is what the basically the lab side is how the information flow and what kind of tool and platform and so on. This is basically brief uh, here. Here I have a demo. I hope I can play this and maybe you can see this is the people with occupants devices with a controller and to what's displayed on this head-mounted display is exactly what on this what you see on the monitor. He see this virtual robot and then through his hand motions to drive and control the robot's hand to complete the task. So I just play this, and this take maybe a few seconds. Hope it moves. Great. So this was the developed based on the ABB manipulators, robot hand, and this team participated in this hackathon, Industry 4.0 hackathon. So because this project, they made the third place in this hackathon among the 50 of the more than 50 teams. So they did good job there. Oh no. Here is what the research you were doing related with this 30% threshold, 30% robot enabled smart lab. So we are studying on how we going to do the multi-robot path planning in the indoor environment. So basically, we want to use A-star to do the global path planning. Then we will start furthermore how we use optimize the path planning, use reinforcement learning to avoid multi-robot collisions, to the optical avoidance and so on. And also you see this, for instance, towards the fork-based human-in-loop cyber-physics system for the human-robot interaction in the smart lab. We develop the user case, develop the architectures. And also we are develop the various of the human computer interface through the dynamic prototyping. This is also one thing we're working on. And we also going to do some more research on how the cloud services, especially on-premise fog cloud, in this case, going to enable and enhance this whole system, and also try to continually work with on this virtual reality, augmented reality, and mixed reality. So one of the mixed reality, what we're doing is we want to develop with this virtual, I just played there, with the virtual robot, but in that play, the robot is just a manipulator, it's a robot hand. If it is a 30% robot, we will create a same exactly virtual robot of the real robot, 30% robot. And why we are use this real robot, the kinematics and dynamics, to create the one and create and enforce this to a real environment. Then we can use the virtual reality gears to drive, control this virtual robot. And while we're driving this, control this virtual robot, we are also drive this real robot at the same time to create kind of a master-slave robot teleoperations. And also the real robots, the radio fading, that means what they see, going to be superimposed on this virtual robot, virtual telepresence robot itself. Therefore, the user, through the head-mounted display, they will see the virtual robot and the real fading of the real robot. So this is what we are doing now. So this project, I hope that we can finish in the end of this month. And learning analytics. Learning analytics, we basically want to learn how the people doing the this kind of 30% remote lab, 30% lab, what is their behavior, how they're, what we can help to basically analyze the student behavior, how the complete rate and so on, for the what kind of pedagogy and so on. We need to be better engaging the student, better design the lab work to suitable for this 30% systems So that is more like a pedagogical issue. Yes, that is one thing is how we use these robots. We think this is kind of pedagogy issue, and also is how we can design what we are traditionally designed lab work, how we going to modify this traditional design lab work to fit to this telepresence system. So this is we put in the pedagogical issue. Of course, finally, educational evaluation and the system validation. System validation is obvious how the system, how the usability and the people's experiences and so on. And the education evaluation is how this lab work. The online telepresence enable this lab work to help the student feel hand-on. And also, of course, is how to save the University Institute to provide the larger meaning of the lab. So maybe there's economic advantage and so on. So that is what we're going to study on. So now I just finished this part of my presentation is about the telepresence lab. Later on, I'm going to continue for the part of third part. Let's talk about the location-based mobile adaptive mobile learning. So it's okay to continue like this, eh?
Yes, sir. Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay. So I continue. I don't want. Maybe I lost you. Okay. For the next part, basically, I just want to review some previous research I have did in the location-based adaptive mobile learning. Oh. First, what's that? Okay. So mobile learning obviously is from learning from mobile devices through the mobile. So this is mostly what I talk about is a mobile smartphone. So this is almost like the has been developed for a long time. For instance, we could use a mobile device to scan the QR code. Then the mobile phone could display what the more background information of this plans and so on. This is a type of situated learning. So for the mobile learning management, basically mobile learning itself, the content has to be managed by the learning management system. And the only difference is the mobile device, we just access the mobile content through the mobile devices or from the smartphone. It wasn't this one is from BlackBerry. It's a very long time, more than 15 years ago, I believe. So we thought this you have to display the information on the mobile devices. So that is all this about this concept of how the mobile learning and the mobile learning system will be. During this mobile learning, because when I started to work on the location mobile learning, then I think realize there's one thing the mobile learning difference with what we call the traditionally called the e-learning, that the learning based on computers, is any mobile phone is location awareness. Because the mobile phone, you want to work, you have to know where you are, because you have always have to talk to the mobile cellular towers. So therefore, location awareness is one of the feature, and let's see, it's an outstanding feature for the mobile devices. Therefore, in the mobile learning, we can add the location content into this mobile learning. So in that case, I proposed that's a 5R adaptation framework. So what means the 5R is basically in the right time, at the right location, through the right device, deliver the right content to the right learners. Because I know where you are, I know where you are, what time you are in there, and I know what kind of device you have. For instance, you have an iPhone, or you have an Android phone, or a larger phone, and also because of your different devices, and I know who you are, I can package in this content as suitable for you at that time, at that location, and deliver to you. So for this, we later on we have some development to show this example how this 5R works. This basically will use one of the application we developed because we use a 5R adaptive augmented reality system. What that means, we use a mobile device to, when we go to particular location, alien location, then this mobile device will point to one of the, we call the learning object, the physical learning object. Then the mobile device is going to understand what is learning objects are or is. Then they're going to, according to who are you, what time you are there, and they're going to pump some information about this particular learning object. This is how this system works. So this is architecture and little bit detail about this system. So the concept like this. This picture, what you see is Alberta legislature. This is one of the old building in Edmonton, the capital city of the Alberta province. So therefore, this building itself contains a lot of information. We see it could be, so this information could be accessed, this particular learning object could be used by different students, different people. For instance, if you're the people, a person who are learning political science, this is our legislature, then maybe display the political science information, talk about our governance, talk about who is our premier, who is how many parties are they, who each party have how many seats, who is the opposition leader, and so on. So who is the governing party and so on, could all related with the political science, this type of information there. But if you're the architect, this building was built in 1905. It's designed and more like it's a Norman type of European designed buildings. It could be provided the architecture information of these particular buildings. For instance, if you're just, for instance, English study and so on, maybe provide some English learning contents related with this building. So therefore, we could, based on the location, that means this particular location in the legislature, and based on the time and who you are, give your right learning content. So this is a show, and the screenshot is when the student points their mobile device to this learning object, then they realize this is whatever building. Then, for instance, according to who are you, then the content will be displayed on your overlap on this particular images. So this was done 2015, I believe. That is we are celebrating a centennial for the Alberta's 100 years. Another one is location-based grouping. So what I said in where, if you record, I mentioned the online learning, distance learning. The big issue is students feel isolated. They are not inspired by the peers. So what I made this research and developed called the location-based grouping algorithm. What this algorithm does is basically according to where you are, we can suggest you create a kind of a virtual classroom around a virtual campus around you, because we do have the case like for instance, I with a student that have the labor, they are taking the same course at my class, but they are never talk to each other about they are taking course in the Aspasia University networking course. Through they are using this mobile device to do this lab work, do their do the mobile learning study. Then this application could identify, oh, nearby you there is this person taking the same course, in the same class as you. Do you guys want to meet somewhere? Maybe you can meet each other in the cafe or somewhere to have the peer-to-peer interactions. So this algorithm basically based on the student profile, students' learning behavior, learning style. We can, and of course the location. Then we propose the group. The group we call basically this learning group is kind of created almost student we are in the city or somewhere, is almost like the campus. This virtual fence, the perimeter we sit in the 2 kilometer range. So that means the nearby neighbors. So you can meet each other. So this is one way to collaborate like that. Second grouping is by interest. So even I'm a computer science student, but today I'm interested with the mechanic engineering stuff. Therefore, I can pick my interest. Is there any mechanical engineering students or colleague or so on around me? Then I can interact with him. So that's based on the interest. And the third is basically purely based on the location. For instance, if you use this application system, when I go to Cairo, Egypt, I have some students there taking the course, and we're running the same application. I can say, oh, within 2 kilometer or 5 kilometer distance, oh, there is Aspasia University students in here. So maybe I could use this opportunity to meet him and to socialize, interact. This could be a location-based social network. So this was still developed 2008. It's a very long time ago. So this is a little bit detail about the location-based dynamic grouping algorithm itself. So, oh, excuse me. Sorry, sorry, a little bit disturbing. I smell something. Yeah, it's fine. So sorry for the interruption. So this is basically show me what the interaction, how this algorithm works. So this is what I'm presenting here. Yeah. Next one. So this is how the virtual campus, the very simple concept idea, how they're grouping the student together and so on. This is a screenshot of the mobile virtual campus, this application. So this is the screenshots of the application itself. I call the VMVC, Mobile Virtual Campus. This is another I call the iWhiteboard. What we do is basically develop the application for the students who are, for instance, both of us with this particular application, we call the iBodies. So with this application, I can use the mobile application to show the exactly same scenery and ask a lot of people share with my body. The body will be see the same thing. Then I can interact with the screen to ask a question or something. Then the other side, they can respond to me. So I call the iBody. So it's also called the iWhiteboard. So this is one of the application. This is very good for instance, if the Indian student come to visit me here, you don't know the environment and so on, we can assign a lot of students who are local, become their bodies. They can both run this application. Then if they go to restaurant to order something, you can show the menu. Then maybe a lot of local students can help the order and so on. So this is of course, it's also for the learning purpose. You can use this application for the learning. And yeah, this is one of the open education resource projects we did. We got with Professor Fred People in our science lab, science center. Basically, we developed based on the location-based the mobile learning concept, deliver the field trip, the pre-designed field trip, and according to where the students, the location and the time and so on, we deliver the field instruction and instruct the students to see what are around them and ask questions and so on to do the field activities. So this is what the mobile field trip is. Yeah. Now I just go to the third, fourth part. It's introduce some larger research and development project I'm involved with. Some important one. Now I have one PhD student working with me. We're develop the blockchain-based use the blockchain technology to develop the instructional design and the learning content creations. So because the blockchain technology have a high security and also is a shared network and have a shared trust network and the trust and different people use the concern process could engage with use a smart contract and so on to do create the learning content. Idea is, for instance, I write the cloud computing course, deliver the course as is. Then when the people come in, even the students and the experts and other subject experts and so on, they can do is to add new content related with my course, the course. So how they do that? Basically, with blockchain technology, use a smart contract concept framework to allow the people to add their new content for the courses. So this is what one of the research we're working on. They're dealing with a lot of theoretical and the practical issues on this research. And also I made a lot of series of research on the privacy issue to particularly study and engaging with people to study the privacy how for instance, in the big data case, what's the big data privacy, what's the big data privacy, how we should be change our perceptions about the privacy, what is the privacy. In there, we are talking about, for instance, our online is our digital life. Therefore, we going to have our digital footage there. And also, if we use social media, I define them as a digital stage. If you use the social media, no matter you are active or inactive, or even you don't speak, your behavior, you're acting there. So you're on the digital stage. And also we are using mobile device, we are using smart device. This, I said that this device is your personal trackers. So where you go, what you do, these devices has fully tracked you, everything. So where in this case, we're talking about what is the privacy to us now. So from the concept to we're talking about in the big data, this kind of era, this environment, your information not being known has become very, very difficult, almost impossible. Your information is there. Your digital footage is there. But the privacy, what we should more focus on is who knows what information, who knows the information. Some information you could share with your colleague, but you are not share with your family. That means this information to your family is your private information. Some information you share with the family, maybe you don't share with your friends. So the sector of the information become important. So this is what we are more in this paper. We talk about changing the concept, perception of the privacies, and we have here is we also have different papers and research essay and project to study privacy issues, and include the social network privacy, cloud computing privacy, and the dark web, and the IoT, Internet of Things, the security and the privacy. So all this is very, very important. So this, what I would do later on is how we voice to Industry 4.50, that means human-machine interaction, how we respect the people's privacy and respect the machine too. So that is a later study will be coming. And another research I recently involved is we call the telemedicine. Basically, we developed a mobile application called Doctors on Hand, the mobile application. Use this mobile application, the doctor and the patients can communicate through the mobile device to do the medical consult. So this is particularly useful for this COVID pandemic case. It was now in Canada we have a public health system. So it was when you have a problem, you go to see the doctor. You don't need to pay anything. So doctor that charge the government. But therefore, it was you have to show face-to-face, in person to the doctor office, to the clinic to get a medical consult. But now, because of the pandemic, they are allow people use a phone, use the mobile device to do the doctor medical consult. So this is a very timely application. And for me, one thing we developed this application itself, and another thing from research-wise, we want to study through the uses of mobile devices to study very sensitive medical and health information. Privacy, security, and related all this information, we want to do the study. So this is telemedications. And also dealing with, that is also several years ago, dealing with develop remote sensing monitoring system for long-term care facility for senior people to understand For instance, some senior use RFID to particularly pinpoint their locations and find out, especially for the people who need 24-hour help. Some patients or seniors, maybe they need 24-hour help to even go to the bathroom. But when during the night, they wake up from dream, they are suddenly going to get up to go to a washroom and so on, then they could cause a fall. That is very dangerous and a very big, highly incident in the long-term cares. This monitor system want to do is to identify the people's gesture postures before they really get up. We send an alert to the health care ad or to the nurses, so to prevent this kind of falling incidents. Yeah, so in the last 1.5 hours, I had talk about all these issues. So first, of course, I introduced the university and so on, and what we see is like telepresence robots enabled smart lab. This kind of a remote lab is a very complicated system, and also dealing with a lot of academic research and practical development issues. So this is very, to me, is very interesting, and also for our university or for the people who are doing work online and want to remote access. I think it's going to be I have a lot of passion for this kind of solutions. So this is I think there will be very important research for me in my future academic careers. And also I mentioned about the mobile learning, and that is even this is more from a research side, but now we know the mobile device has been used more and more and better and really widely be used. So therefore, engaging with a mobile device enabled education as educating media is can be important, one of the important way of deliver the education, deliver the learning contents and so on. And when we deliver the learning contents and so on, the learning framework is very important. And how we deliver, how we take advantage of online and e-learning, online learning, and mobile learning, and also to fill the gap of the what this distance learning or online learning, like the traditional university, is one of the things we can, through our technology means, to contribute to dealing with this issue. And to increase the online learning has been starting to be more and more adopted by the people, especially we can see this pandemic help the people to university and the students to teaching and learning online. So therefore they become more adoption, and could become one of the trends of the one way of education's trends. And I also believe location-based mobile learning, for if we are implement a lot of learning content delivered through the mobile device, they have a great potential to implement the personalized and adaptive to the learners. So that have a lot of learning opportunity there. Okay, so thank you for for your attention. So this is what my presentation. Thank you. Takes a very long time, 1.5 hours.
Thank you, sir. And couple of questions are there. Can I take the question now? First question is, give an idea about optimization in robotics.
Go ahead.
Mr. Sir, you can.
Give an idea about optimization in robotics.
I did an idea of the what?
Your question is not.
Optimization in robotics.
Yeah, optimization. You mean?
Yeah. Yes.
Yeah. From optimization, what we are more focused on is more focused on the autonomous way, because in whole this whole solution, telepresence robot is the main component. Mainly, we are not really research on the robot itself. I know you're maybe you are in the mechanic, the communication. You have electronics in this kind of. We're not particular studying robot itself, but we're using robots. So we want to create this platform can engage any, let's say, any type. But of course, we cannot. But most type of different type of robots, 30% robot for the different purpose. Therefore, what our main focus is how we control, manage the robot moving in the indoor environment by manually drive or leading drive or autonomous drive. In the autonomous drive is a fashion, so we can use some machine learning algorithm and also try to apply some artificial intelligence to optimize plan for the path planning and optical avoidance, all this, and optimize indoor robot traffic to avoid the static or stationary obstacle or dynamic obstacles. So that is what my focus for the robot side. It's not robot control itself. It's how to plan the motions in the lab.
Okay, sir. I will take one more question. Can telepresence smart lab helps for collaboration of research work keeping domain common to all?
Yes, I should say yes, because if I understand your question right, you said that can 30% robot enable smart lab can help the research collaboration. If this is the question, I will say yes, because for instance, when we do the research, especially we doing some research need to be hand-on together in some way. Maybe we can use this system by we are signing into the robot in that particular location. We have a research happens. Let's say your workshop, mechanical workshop. Then instead of you use this 30% like the teleconference, show me and so on. Maybe if I'm a robot beside you at Avatar, make your research communication and on-site show and handing on things is much more easier than you just have to, you don't need to take care of me. So I think that this kind of 30% going to help to integrate the people feel more closely. Now when we are use this online conference software like the Google Meeting, we are facing, okay, we're 2D communication. I see you're sitting there, I'm sitting there, talk. But when we need to act on something together, then we have a limitation. So this is therefore, if we have a robot avatar, as both of us, you're in India, I'm in Canada, we can have a robot, the robot in the same place. Let's say we have a lab in India, or we have a lab in Athabasca in Canada. Then we can working together as if you were there. This is what I think. But of course, depends on what kind of research, how effective. But this solution mainly is for students to conduct some science lab work or field work. For instance, for the it's a telepresence technology. For instance, we go to a slow measurement. Maybe even the instructor or the professor can wear the GoPro or something devices, and the students with the communication gear, and the students can go through the GoPro camera and so on behind online to see how the professor or researcher working in the real field, how to use a slow measure tool, how to do the GPS location, set the target, and all these give their in-person as if they were present in the location, this kind of feeling. So we are more towards that. Yeah.
Okay, thank you very much, sir, for
Thank you.
enriching our knowledge on teaching learning pedagogy, especially on sharing your hands-on experience on telepresence smart lab. We are hopeful that in future we shall continue our collaborations. Thank you once again, sir, for delivering your talk during the late night hours in Canada. Thank you, sir. Good
Thank you
night.
very much. Thank you very much, and I really appreciate. Very nice to meet you all, and
Okay.
thank you for inviting me in this. We keep in touch. Hope we can find some common interest. Eventually, we can have a collaboration in teaching and research. For
Thank you, sir.
okay, thank you.
Okay, good
Bye
night,
bye.
sir.
Thank you. Bye. Bye bye. Thank you.
Thank you.